Hello everyone, welcome back to another episode of Math Unlocked, and I'm your host, Mrs. Rhodes-Grierson. So in this session, we are doing a three-part of factorization, and what we want to do is to factorize an expression that has two terms in it. But for this lesson, we're going to focus on expressions that actually are a little bit more advanced than the one that is presented on the screen. But I'm going to start here for you to get back to the foundation so that we can get understanding, all right? So I have the expression that has term 1, xp, term 2, yp. When we factorize, what we're looking for is the highest common factor. Now in this, we know that there are no numerical factors here, but there are only variables that are stated. So I know that xp is divisible by x, is divisible by p, and it's divisible by xp, because all terms are divisible by themselves. So I could break it into parts, xp and xp, while over here, it's divisible by y, it's divisible by p, and it's divisible by yp. Now when we look for the highest common factor, we're looking at what is it that they have in common, and it's the biggest thing that they have in common. In this case, I noticed that both of them are p in common, so I'm factoring out p. Factorizing means that we're rewriting the expression before as a product, so that means the p will be multiplying, and the bracket here without anything separating it implies multiplication. It's multiplying another term, another number here, or another variable in this case, plus it's always be multiplying something else there, because I take note that there are two terms that are being factorized. So inside my bracket, I should account for those two. What is p multiplying to give me xp? P would multiply x. What would p multiply to give me yp? It would multiply y. So in factored form, I take note that what they had in common was p. So p is the factor that I brought out. The other two factors which are written here is what p would multiply to give me my two terms that I would have had in the original statement. All right? So we're going to use that information to do some more complex factorization. All right, so let's look at this expression. And I want you to take note that the expression has two terms. It might look more complex than two terms, but it has two terms. So the first term here would have been a x plus 1. All of this is one term because the a is attached to the expression here by multiplication, which is what creates that one term. Plus b is multiplying x plus 1, so this is my next term here. I wanted to take note that from the two expressions, the two terms that are here, they have something in common. Both terms are multiplying x plus 1. So a multiplies x plus 1 and b multiplies x plus 1. Since both of them are multiplying x plus 1, it means that both of them are divisible by x plus 1. Therefore, x plus 1 is a factor of both. So to factorize this expression and factorize it by the bracket itself, this bracket is what they have in common. So the common factor would have been the entire expression of x plus 1. So remember now, when we factorize, we're going to use the common factor to multiply, opening another bracket. There's nothing separating these two brackets because we're multiplying. So this factor will multiply two things because I had two terms here. The first thing that it will multiply is that it will multiply a, because x plus 1 multiplies a to give me back that expression, plus x plus 1 was also multiplying b here. So here I will put in my b. And the expression now has been factorized, where the common factor was an expression in itself, which was x plus 1. So to factorize a two-term expression where the common factor is an expression, we take the same root but acknowledge that what we're factorizing by is not a single term but an entire expression.